Let's continue our discussion on advanced dimensionality reduction techniques. By the end of this topic, you will be able to explain and implement forward selection technique of dimensionality reduction. Let's first look at the algorithmic approach to understand the forward selection. Step 1 is, for every independent variable, build a linear regression model individually. Choose the independent variable with the highest adjusted R² score and call it variable 1. Now again, repeat the above process by using the var1 as the base independent variable and combining it with every other independent variable to build a regression model. Choose the combination with the highest adjusted R² score. Step 3 is to repeat the above process until the maximum number of features has been obtained or the adjusted R² score is no longer increasing. Well, the algorithmic approach is complicated and confusing as expected. So let's break this down. In step 1, we simply choose one independent variable from the complete set and use it to build a regression model and record the corresponding adjusted R² score. Suppose the V5 yields the maximum adjusted R² score. As a result, it will now be the first independent variable of our final model. In the second step, we will again build a linear regression model, but this time it will be a combination of all the remaining independent variables and previously chosen independent variables, and we again choose the combination with the highest adjusted R² value. Now consider that V9 is the new variable that has been chosen in the second iteration. As a result, we have two independent variables fixed, and then we will again iterate through the combination of the two fixed independent variables and the remaining independent variables. We repeat this process until we get the desired number of best features or until the adjusted R² value stops growing or starts reducing. This method is used when we face a question like, let's say that we want to have the best 5 predictors which contribute to the model in the best way. Such a model is chosen for the sake of simplicity and easy interpretability. Let's start by defining a small function with the name return_R2. This function will return the adjusted R² score with respect to the independent, dependent variables and the model. This function will take 3 parameters: independent variables, target variable, and the model. Inside this function, we fit the model over the independent and the target variable and generating prediction. Now we are using the adjusted R² function which we defined before and pass the required parameters to that function. The result returned by the adjusted R² is returned by this function. Now we will define the primary function called forward elimination. This one is going to be a difficult ride, so hold on tight. This function takes 4 parameters, that is model, which is any predictive model we would like to use, x and y, which are the independent and target variables, max features, which is the number of maximum features we want in our model. We will start by initiating the f_col and history as blank lists. f_col will store the variable being selected at each step of forward selection, and history will store adjusted R² values whenever a new feature is selected. Now in line 17, we are running a loop until the maximum number of features are selected. Inside this loop, we initialize 2 variables. We are adding a new element to the fcol list. We are doing this because it will be updated whenever we encounter a candidate for best feature. In the next line, we copy fcol into tmp. You should note that we are copying all the elements and not the list itself. We also initialize rmax as -1. This variable will keep track that adding which variable produced the maximum adjusted R² result. Now in line 23, we iterate through every column present in the independent variables dataset X. In any given iteration, the last element of tmp is assigned as the new column to try. Now we pass these columns to the return_R2 function, which we have already defined before. That function will return the adjusted R² associated with adding the new column and store it in the R2 variable. In line 26, we are checking whether adding this new independent variable has the highest score encountered so far in this cycle. If yes, then update the rmax value to R2 and copy the column name at the end of fcol. This process is repeated for every independent variable, and at the end of a cycle, the new independent variable with the highest adjusted R² is retained in the f_ column. This process is repeated until the max features is reached and the process stops. At last, the function returns three things to us, which are score of the best possible model with maximum features, history of the adjusted R² score on the addition of every feature, and the set of features in decreasing order. Now comes the final part. We call the forward selection function, which we have defined, and pass LR as model, which is an instance of the linear regression class. Xtrain as the set of independent variables, Ytrain as the target variable. For now, we mention 5 as the max features. The function should return the top 5 features. So let's run this. In the output, we can clearly see each column being selected every cycle and the corresponding adjusted R² score. In case you are struggling to understand this code implementation, we have provided the Jupyter notebook with this code at the end of this topic. Please spend time going through each line of the code in that and try to understand what is happening there. With a bit of thinking, you would be able to figure this out yourself. I would suggest you to play around with the parameters and observe how the values of adjusted R² score varies with the addition of the new columns. Now that we understand the forward selection in an intuitive way, it is now time to shift our focus towards the backward elimination, which we will go through in the next video.